Your average star lives for millions of years and changes through time as it has many stages in its life cycle. Each star produces immense amounts of power, but how is something with such power and energy formed? Let's have a look. It begins with a nebula, which is a cloud of dust. This then collapses to form a protostar. The star grows in size and then becomes a main sequence star, like our Sun. From here, the star has two paths, either a red giant or a red supergiant. If the main sequence star is smaller, it becomes a red giant. When coming to the end of its life, it begins to shrink in size, but heats up so it takes on the white coloration, hence being called a white dwarf. Over millions of years, the white dwarf cools and forms a black dwarf. The other route a star can take is if it turns into a red supergiant. This eventually becomes unstable and explodes. This is a supernova. If the red giant is very large, it forms a black hole, but usually a neutron star is formed. A star begins as nothing but particles of dust and hydrogen atoms. These particles of dust and hydrogen accumulate to form a large cloud known as a nebula. The nebula keeps increasing in size. Some can be light years across. When they increase, its gravitational strength increases. This then attracts more gases and dust to be drawn in until the cloud is significantly more dense. The cloud then undergoes a gravitational collapse as it can't support its own weight. This rapid compression of dust and gas causes the nuclear fusion process to occur, and the ultraviolet radiation ionizes the surrounding gases, making the process visible to our eyes. A protostar has been formed. The protostar is constantly growing in size, and it becomes so much bigger it is no longer classed as a protostar, and then becomes a main sequence star, which is one of the more stable forms of the star. Red dwarfs are another type of star that can occur after the main sequence. However, they aren't very common, they only occur in very small stars. These are very cool, faint and small stars, approximately 1/10 of mass and diameter of the Sun. They burn very slowly and have estimated lifetimes of up to 100 billion years. The smaller of the main sequence stars follow this process. The main sequence star swells up as it runs out of hydrogen as a fuel for nuclear fusion, and the outermost layers cool considerably, changing the appearance and the colour of the light produced to a vivid reddish-orange. The red giant begins to get too large, and so its gravity can't hold in all the layers, so it begins to lose outer layers as planetary nebula. A white dwarf is a very small hot star that is in the last stage of its life cycle as a star, such as the Sun. White dwarfs have a mass similar to that of the Sun, but only 1% of the Sun's diameter, meaning they are much more dense. The surface temperature of a white dwarf is 8,000 degrees, or even higher, but being smaller than the Sun means they appear much less bright. White dwarfs are stars whose nuclear energy supplies have been used up. They have a very high density due to gravitational effects. For example, a spoonful weighs several tons. White dwarfs cool and fade over several billion years. When they are totally cool, they stop producing any light and thus become a black dwarf. Next we have red supergiants. These are formed from the larger main sequence stars. When they run out of hydrogen to use in the fusion process, they expand massively and can be anywhere from 10 to 100 times the diameter of the Sun. But they do tend to have a lower surface temperature, usually around 2,000 to 3,000 degrees. A supernova is the end of the red supergiant phase. It's an explosion that's over 100 million times brighter than the Sun. There are two types. Type 1 occurs in binary star systems, in which a gas from one star reaches a white dwarf, causing it to explode. Type 2 occur in red supergiants, where the internal nuclear reactions become out of hand and end the life of the star as it explodes. They leave behind a neutron star or a black hole. Now it's either a black hole or a neutron star. Neutron stars are composed of mainly neutrons and are produced when a supernova explodes, forcing protons and electrons to combine. Neutron stars are very dense. Typical stars have a mass 3 times of the Sun, but a diameter of only 20 kilometers. If its mass were any greater, its gravity would be so strong that it would shrink further to become a black hole. Black holes are believed to have formed from massive stars at the end of their lifetimes. The gravitational pull in a black hole is so great that nothing can escape from it, not even light. The density of matter in a black hole can't be measured, as black holes distort the space around them and can often suck neighbouring matter into them, including other stars.